Fundamental Identities of Trigonometry. In ancient Egypt, rope stretchers discovered that a rope tied in a circle with 12 evenly spaced knots could be used to form a right triangle. This shows that the Egyptians back then knew about the 3-4-5 triangle and used this knowledge in the construction of pyramids, temples, and other buildings with perfect right angles at the corners. Pythagorean theorem states that, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. C squared equals A squared plus B squared. Pythagorean theorem states that, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. C squared equals A squared plus B squared. 25 equals 16 plus 9. 5 squared equals 4 squared plus 3 squared. 16 equals 25 minus 9. 4 squared equals 5 squared minus 3 squared. 9 equals 25 minus 16. 3 squared equals 5 squared minus 4 squared. Pythagorean theorem rearranged. Pythagorean theorem, when rearranged, states that the result of subtracting the square of one side from the square of the hypotenuse is the square of the third side. A squared equals C squared minus B squared, and B squared equals C squared minus A squared. Either trigonometric ratios or the Pythagorean theorem is used to find unknown measures of sides in a triangle. According to the Pythagorean theorem, in a right-angled triangle, square of the side opposite to angle theta plus square of the side adjacent to angle theta is equal to the square of the hypotenuse. Dividing both sides of the equation with hypotenuse square, we get opposite side by hypotenuse squared plus adjacent by hypotenuse squared equals 1. We know that opposite side by hypotenuse equals sine theta and adjacent side by hypotenuse equals cos theta. By substitution, we get the first Pythagorean identity. Sine square theta plus cos square theta equals to 1. Once again, let's consider the equation representing the Pythagorean theorem. Square of the opposite side plus square of the adjacent side equals square of the hypotenuse. Dividing both sides of the equation with opposite side square, we get 1 plus adjacent side squared by opposite side square equals hypotenuse square by opposite square. We know that adjacent side by opposite side equals cot theta, and hypotenuse by opposite side equals cosecant theta. By substitution, we get the Pythagorean identity. Cosecant square theta minus cot square theta equals to 1. Let's prove the identity secant square theta minus tan square theta equals 1 using the Pythagorean theorem. In a right-angled triangle, square of the opposite side plus square of the adjacent side equals square of the hypotenuse. Dividing both sides of the equation by adjacent side square, we get opposite side square by adjacent side square plus 1 equals hypotenuse square by adjacent square. We know that opposite side by adjacent side equals tan theta. and hypotenuse by adjacent side equals secant theta. By substitution, we get the Pythagorean identity. Secant square theta minus tan square theta equals to 1. Summary. The sub-formula using fundamental identities. Sine square theta plus cos square theta equal to 1. Sine square theta equals to 1 minus cos square theta. Sine theta equals to square root of 1 minus cos square theta. Cos square theta equals to 1 minus sine square theta. Cos theta equals to square root of 1 minus sine square theta. Sec square theta minus tan square theta equals to 1. Sec square theta equals to 1 plus tan square theta. Sec theta equals to square root 1 plus tan square theta. Tan square theta equals to sec square theta minus 1. Tan theta equals to square root of sec square theta minus 1. Sec theta plus tan theta multiplied by sec theta minus tan theta equals to 1. Sec theta plus tan theta equals to 1 by sec theta minus tan theta. Sec theta minus tan theta equals to 1 by sec theta plus tan theta. Cosec square theta minus cot square theta equals to 1. Cosec square theta equals to 1 plus cot square theta. Cosec theta equal to root of 1 plus cot square theta. Cot square theta equals to cosec square theta minus 1. Cot theta equals to root of cosec square theta minus 1. Cosec theta plus cot theta multiplied by cosec theta minus cot theta equals to 1. Cosec theta plus cot theta equals to 1 by cosec theta minus cot theta. Cosec theta minus cot theta equals to 1 by cosec theta plus cot theta.